Trigonometry. This trigonometry is going to use in studying these angles. Okay, how it is? Suppose this is a giant wheel, and this giant wheel is rotating. This giant wheel is rotating. How much it is rotating? Just we want to know. So, in what terms we are going to measure? First of all, if you look at that giant wheel, you may need to identify what is the direction of that rotation. Is it moving like anti-clockwise or clockwise? And how much it is rotating? That we want to know. So that's why we need a system to understand it. Understand it. Suppose if we divide this into this part, and however, if it is completing one revolution, one complete revolution, how much it has completed? That that we need to answer. Okay. So to answer this question, we have four methods. Four methods. First of all, we can use one thing. If it is moving anti-clockwise direction, if it is moving anti-clockwise direction, the angle is going to be measured as a positive. Positive. And if it is rotating in a clockwise direction, you are going to take it as negative. Means if, now I am showing in the diagram, it is rotating in anti-clockwise direction. If it is anti-clockwise direction, and if it completed one rotation, it has completed the 360 degrees from here to here, here to here. It has completed 360 degrees. 360 degrees. So that 360 degrees, are you going to say in a positive or negative? Surely we are going to say as positive. Why? Because it is making anti-clockwise. Anti-clockwise. If it is making clockwise direction, the same 360 degrees you are going to answer, but it is in negative. This is going to be in negative. We have to understand. Okay, that is going to be the negative. Negative. So this is just to make you understand only the directions in which direction it is rotated. But in one revolution, how much it has completed? To say that, we have four different systems to answer. Four different systems. What are those four different systems? Number one, number one. It is based on 60. 60. It is going to divide. That's why it is a sexagesimal system. In this, what is the point? What is the point? The angle is going to be divided with 60. For example, one right angle equals to one right angle. One right angle means, that means 90 degrees. 90 degrees are going to be this equivalence. And at the same time, what is the meaning of 1 degree? What is the meaning of 1 degree? It is going to be 60 minutes. 60 minutes. If it is going to be said as a minute, you are going to represent with one line only, 60 dash, like that. And what about 1 minute? What about 1 minute? It is going to be 60 seconds. 60 seconds. Again, seconds is going to be represented with a double dash. This is one kind of system. This is one kind of system to represent or to understand what is the magnitude of that rotation. Magnitude of that rotation. If you go for the second system, if you go for the second system, that is going to be centesimal. Centi. What is the meaning of that centi? If you understand, okay, if you think about it, it is 100. Centesimal system means the name itself, it is representing, that is going to be make as 100 portions. We are going to divide that into 100 portions. Okay, 100 values. Suppose one right angle equals to one right angle that means 90 degrees. That 90 degrees equals to 100 grades. It is going to be divided as 100 grades, means 100 portions it was made, 90 degrees. Okay, so 1 grade equals to, again, 100 minutes. Again, 1 minute is equals to 100, like double seconds. It is going to be centesimal it is going to be represented. Okay, and another system, whatever we are going to use is circular system. In this circular system, as we have some relations in the above systems, here also we are going to measure n radians equals to 180 degrees. N radian equals to 180 degrees. In case we are going to measure circular system radians, we know that if it is an arc, which is making some angle, here it is some theta, and its radius is r, its length is like AB, and origin is O. What is the arc length? What is going to be the arc length? And here in this, it is making circular motion, rotation it is doing. That's why theta is our importance. That's why we will write angle theta, angle theta is going to be equal to arc length divided by radius of circle, or radius of that arc, radius. So this is one system, or circular system, what we are going to use to find the magnitude, how much rotation it has completed, Next, another system. Here in this 1 degree is equals to 1 radian, we are going to measure. In case of our theta is going to be 1 radian. So theta equals to 1 radian in circular system. In another system, radius system, radian. In that, what is going to be theta equals to 2 pi radians. Theta equals to 2 pi radians. So when it is completing one circular motion, one object is making one circular motion. Maybe it is giant wheel or fan or minute lever in clock, like whatever it is. If it is completing one revolution, what we are going to say, 2 pi radians is equals to 360 degrees, because it is completing one revolution. So one complete revolution. That means it is going to be 2 into pi value as 22/7 we are taking here, the 3.14 into radian equals to 360 degrees. Now if you take what is going to be 1 radian, so 360 divided by 2 into 3.14, this value. So what is going to get this? We are going to get the value as 57.3 approximately, 57.3 degrees approximately. So in this system, 1 radian equals how much degree? 57.3 degree. So these are four different systems to identify the magnitude, how much it has rotated. But in which direction, we already clear. It is anti-clockwise and clockwise. So based on that, we are going to take the sign convention, plus or minus, like. Okay, so if you want to know that the total one complete revolution, we are going to divide into 4 parts. What is going to be that 4 parts, and what is the angle? Let us check here. So if it is making one complete revolution, in how much angle we can divide to understand it. So it is four parts we are doing just four parts, and it is actually one revolution. Already just now we spoke, it is a 360 degrees, that was divided by four parts na. 360 by 4, how much is going to be there? 360 by 4, it is going to be 9. So each one is 9. We can understand, each one making 90. Okay, so if it is only four parts, each one is going to be said as quadrant. The first quadrant, if it is the first quadrant, if it is the first quadrant, it's a quadrant. In first quadrant, what is going to be the limit? What is going to be the limit? We have to understand. If we are thinking that it is starting from here, x, and from here to here it is going to travel, this is going to be the limit of 90 degrees. From where to where it is going to have 0 to 90 degrees. 0 to 90 degrees. In case of second quadrant, in case of second quadrant, so there we are going to find the quadrant is going to here to here. Means if you are starting from, I mean isolatedly, this is the first quadrant, this is the second quadrant, and the third and fourth. Okay, each one 90 90 90, like that, 90 plus 90, 90 plus 90, like we are going to add. Okay, for the second quadrant is going to be ending, if it starts from, we are counting from 0, it is going to be said, actually it is 90 to 180, 90 to 180. Okay, so in case of next third quadrant 180, after 180 to 270, 270, and just means equal to this 91 after, this is 181 after. Next fourth quadrant is going to be said 271 or 270 after to 360 degrees. These are the angles to understand in the form of quadrants. But if you want to understand where what value is going to be how, we need to understand the basic definitions of the trigonometric functions. So what are those basic functions? Basic functions, if this is right angle, for the right angle, whatever we have the value, right? Right angle, for the right angle. Suppose let us say this is a OMP. This is the base. This is the height. This is going to be the hypotenuse. And where we have taken angle is this. And what is the one angle? This is the 90 degrees. This is a 90 degrees. Now from this basic idea, the definitions I have given for the angles whatever we are going to use. Sine theta. The sine theta is going to be the opposite side. Height is, where is the height with respect to the theta? It is going to be the opposite side, right? Opposite side. And with respect to the theta, where is the base? It is going to be the adjacent side. Okay, so now the sine theta, the definition itself is opposite side by hypotenuse. So then what is the value here? Opposite value is MP. So what is hypotenuse? OP. This is. And whenever we are taking the values like these definitions for all these, we have to remember cos theta is adjacent side by hypotenuse. Now adjacent side is OM. OM divided by OP. Then tan theta is equals to, tan theta is equals to, right? Opposite by adjacent, opposite by adjacent. Then opposite is, what is that? MP. Adjacent is OM. And from the previous one, previous values, suppose sine theta and cos theta, can we get anything? Can we get any relations? If you think, try to do that. 1 divided by 2, what will come? MP by OP divided by OM by OP. Then we are going to get cancel of P. Then again you are going to get. That's why you are going to write tan theta as the sine theta divided by cos theta. Means sine, suppose sine 30 value is there, 30 degrees. Because why we are talking about 30? Because whenever it is completing one revolution, maybe at the position of 30 degrees, at the position of 30 degrees, sine tan 30 we want, then sine 30 by cos 30, whatever you write, you will get that. So what is that value? We will discuss. First of all, let us understand what are these values, okay? And whatever is going to be opposite to the sine. Sine is going to be opposite to the cosecant theta. Cosecant theta. That cosecant theta opposite to the sine means inverse. Mean it is going to be inverse. 1 by sine theta is going to be cosecant theta. Means hypotenuse by opposite side. Opposite. This is the cosecant. Then for cos theta, it is going to be a reverse of secant. Mean you are going to new one by secant, or reciprocal secant theta equals to 1 by cos theta. Whenever you write 1 by cos theta, what will come? It is going to be hypotenuse by adjacent side. Hypotenuse by adjacent side. If you are writing like this, what is that function? It is going to be the secant theta. And next, the cot theta. Cot theta. This is also reciprocal. Cot theta is reciprocal of tan theta. Cot theta is reciprocal of tan theta. Whenever we are writing tan theta, opposite by adjacent. But whenever you are writing reciprocal to that, for getting cot theta, you are writing as what? Adjacent side by opposite side. Adjacent side by opposite side. So these relations, standard definitions and relations, we have to understand whenever we are going to use in the next usage. Suppose what is a sine theta? Suppose when I write sine theta, cos theta, tan theta, cosecant theta, secant theta, and cot theta. These are how one another are reciprocal, that we have to understand. These are the basic definitions. But what is going to be if it is rotating one revolution? If it is a sine, what is the understanding? Let us understand that values to identify sine 30 or sine 0. What are the values, functions? And in physics, why we need them? In case of repetitions, harmonic repeating functions, we are going to use this sine and cos theta. Sine and cos theta. Suppose angle made is some theta. Okay. So that is 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees, if that is the case. And that angle is, for the case of just sine theta, we are taking sine theta. Sine 0 is, so simply to remember, we can use like this: 0, 1, 2, 3, 4. Each one is divided with the 4. Each one just divide with 4. Okay. and simultaneously do the square root to the whole. Square root to the whole. What will happen? What will happen? This is for sine theta. 0 by anything, just is go 0. 1 by root 4, 1 by 2. So 2, 2 ones are 2 twos are 1 by root 2. And now what you are going to do? Root 3 by 2, because square root of 4 is 2. Next, 4 gets cancelled, 1, it is going to be square root of 1 is 1. And next, cos theta is cos theta. For case of cos theta, simply you think whatever values from 0 to 90 you have written, you write from 90 to 0 in reverse. 1 root 3 by 2, 1 root 3 by 2, and 1 by root 2, 1 by 2, and 0. And what about tan theta? Tan theta, just now we know the function. Sin theta by cos theta, if you do, you are going to get the value. So tan value 0 by sin value by cos value 0 by 1, 0, 1 by 2, and 1 root 3 by 2. What you are going to do gets cancelled? This is going to be 1 by root 3, 1 by root 3, and here you are going to get 1, you are going to get 1, and next this is going to be 2 gets cancelled, and root 3, 0 by 1, this is going to be infinity or not defined. And we know what are the reciprocals. If you remember few things, just what is a reciprocal to what? Sin theta, cosecant theta is reciprocal to sin theta, cosecant theta. Then you write 1 by that value, cosecant theta, and next secant theta and cot theta. These are reciprocals to them, whatever we have taken in order. 1, 2, 3 are the same. The 4, 5, 6 are reciprocals to 1, 2, 3. So cos theta, what you are going to write? Reciprocal, right? Reciprocal to that. So 1 by sin theta, 1 by 0, it is infinite, right? Next, 1 by this value, 1 by 1 by 2, 1 by 1 by 1 by root 2. So 2 by root 3, 1 by 1 is going to be 1. The next secant value, secant, it is reciprocal to the cos, reciprocal to cos. 1 by 1, 1, 1 by root 3 by 2, 2 by root 3, okay, 1 by 1 by root. Next, this is going to be root 2, and next this one, this is going to be 1 by 2, and next value is 0 by 1, reciprocal, 0 by 1. This is going to be that infinity, right? 1 by that value. Next, cot theta value, it is a reciprocal. So 1 by 0, again infinity, 1 by root 3, right? This 1 by 1, 1, 1 by root 3, and 1 by infinity, like you are going to get it. This is the tan theta, right? 0. So whatever the values here, we are having the standard values, we are going to use them repeatedly, right? So, and mostly how these values have come, why these are only the values, you will learn more in mathematics. But whatever we need for physics, these values we have to remember. Okay, so these values, especially in case of sound waves, and wherever waves will come, is it mechanical waves or electromagnetic waves, whatever, harmonic and simple harmonic motion, SHM, so rotational motion, right? In all these concepts, we are going to use these sine functions and cos functions and remind. Okay, for example, let us understand why it needs. Just I have 5-meter ladder, 5-meter ladder that was inclined, to the wall, with respect to the ground, only 30 degrees it was inclined. only this. It is a 5 meter, right? At how much height can I touch the wall? At how much height can I touch the wall? Can you answer this question? If we think, if we have the idea, sine theta equals to, sine theta equals opposite by adjacent, right? Sorry, opposite by hypotenuse. Opposite don't know. Hypotenuse is 5. Sine theta, theta is how much? 30. Sine 30, sine 30, h by 5. And sine 30 is, we know the previous values. Whatever we discuss the table, that we have, you have to remember it. Otherwise, you can't do anything. It's a 1 by 2 equals to h by 5. This is going to be h equals to 5 by 2. Okay, that means height of, at how much height to the wall I can touch with the help of the 5-meter ladder. Even though it is a ladder is 5 meter, I can touch only up to 2.5 meter only. Why I can touch 2.5 meter? Because it is inclined 30 degrees. It is inclined 30 degrees. Okay, same thing, same thing. For example, same ladder, I inclined 60 degrees with the ground. 60 degrees with the ground. At how much height can I touch the wall? Can I touch the wall? So that you can understand that it will be definitely different from the previous case. Is it going to be greater or smaller? Definitely greater height. So sine 60, sine 60 equals to h by 5. Ladder is same. Ladder is same. But how much height I can reach? Okay. So by going this way. So sine 60 value, if you remember, so there you are going to get it. Sine 0, 1 by 2, 1 by root 2, root 3 by 2. Root 3 by 2 is the value. And h by 5. H by 5. Okay. So there you're getting, this is h equals to 5 root 3 by 2. 5 root 3 by 2. That means 2.5 into root 3 is going to be the height. What I am going to cover, that is the meter. That is the meter. So like these unknown values can find with the help of trigonometry. So and we have some equations, some formulas to identify and to easily find the relations between all these basic definitions. Whatever we have, sine theta, cos theta, secant theta, cosecant theta, tan, cot, all these to find the identities, relations, additions. For example, we have seen the values in the table, as just between 0, 30, 45, 60, 90. For example, just I want only 15. Sine 15 is how much? Just if I want sine 15 value, I want sine 15 value. Just how we can find it? Is there any way? Is there any way to get the solution or to solve all this? Yes, we have method. For that you need to identify some formulas. So suppose sine of a plus b, or a plus or minus b. If plus is there, okay, plus. If minus is there, what you are going to get? Sine of a plus b, sine of a plus b, sine a cos b, sine a cos b, plus or minus cos a sine b, you are going to get one form. Okay, so how this one is going to help you? So sine 45, how you will get? Sine 45 minus 30. If you do that, what is going to be the value? What is going to be that value that you are going to write? Sine of a place lo emundi 45, b place lo cos 30 minus cos of a place lo 45 into sine 30. All these values, just if you simplify, you are going to get which is the sine 15 value. Like this, many equations, just the fundamental relations we have. If we are aware of those fundamental relations, we are able to solve many problems in the physics very easily. But why we use this concept? We have to understand, especially circular motions and repeated motions. Okay, repeated means sine waves. Just now I told it's a waves, all those, right? Magnetic wave, mechanical wave, whatever the waves. That concept we are going to understand very easily with the help of trigonometry, right? Thank you.